Welcome, everyone, to this comprehensive explainer. Listen, if you're really focused on truly mastering the foundations of computer hardware, you are in exactly the right place. Today, we are breaking down Unit 4, which covers the absolute essentials of secondary storage devices. We're going to look at what these devices actually are, how they function behind the scenes, and why they are literally so critical to every single thing we do on a computer today. Okay, let's jump right into this with a question that gets straight to the heart of our topic today. Have you ever stopped and wondered why, after you completely shut down your computer, like unplug it from the wall, totally power it off, your files, your photos, your videos, and your documents don't just disappear? I mean, we know that the data sitting in a computer's RAM gets completely wiped out the absolute second the power goes off. That volatile nature can be completely terrifying if you haven't saved your work, right? So where exactly does all our important data stay safe and secure when the electricity stops flowing? Well, that is the exact problem that secondary storage solves. So here is our roadmap for today. 1. The storage mystery. 2. Primary v. secondary memory. 3. Secondary storage types. 4. Input and output devices. 5. A real-life data journey. And 6. A final summary. Let's get into it. Section 1. The storage mystery. Unlocking non-volatile memory. So to really understand how our computers keep our data safe, we have to recognize that computers actually use entirely different types of storage for different purposes. Secondary storage devices are specific pieces of hardware used exclusively to store your data long-term, and you'll often hear them called non-volatile storage. And all that fancy term means is that even after the power is totally turned off, the data remains completely intact. Think about a hard disk, a solid-state drive, or even just a standard USB flash drive. If you spend hours typing up an assignment and you hit save, that file is immediately routed to secondary storage, so it's right there waiting for you tomorrow morning. That reliable, long-term retention, that is its absolute biggest advantage. Moving on to Section 2, primary versus secondary memory. Understanding the difference. Now we need to contrast this with primary storage. Primary storage is used for the computer's immediate, right now processing work. RAM is the prime example here. It is volatile, meaning, as we said, it forgets absolutely everything when the power drops, but its access speed is incredibly fast. The computer desperately needs that lightning speed to actively work on tasks. Secondary storage, on the other hand, is built for the long haul. Hard disks, SSDs, and USB drives are non-volatile, remembering everything permanently, and they offer massive capacity compared to primary memory. So the crucial takeaway here is this simple equation. If you want to memorize this easily for your exams, just burn this into your brain. Primary memory equals temporary working space. Secondary storage equals long-term data storage. Primary is where the computer actively thinks and works in the moment, while secondary is essentially this massive, secure vault where everything is kept totally safe when you aren't using it. All right, Section 3, types of secondary storage: sequential, direct, and optical. We can actually categorize these secondary devices based on their access method, how they get to the data, and their underlying technology. We basically have 3 main categories to look at. First up, sequential access devices, like magnetic tape. Second, direct access devices, like your standard hard disk. And third, optical disks, which include things you probably used like CDs, DVDs, and Blu-ray disks. Let's break down exactly what makes these 3 categories function so differently from one another. In sequential access, the hardware is forced to access the data in a very particular, strict sequence. If you want to reach data that's stored right in the middle of a magnetic tape, the drive literally has to physically pass through all the preceding data just to get there. Because of this limitation, it's mostly utilized for massive, large-scale data backups and archival purposes, where raw speed just isn't the main priority. Direct access is an entirely different ballgame. With a hard disk, you can jump directly to the exact required data location instantly. This method is incredibly useful when you need to open a specific file quickly without sitting around waiting to read through everything else first. And to round out our categories, optical disks use laser-based technology to physically read and write the data, which historically was used a ton for distributing music, videos, and software. Which brings us to Section 4, input and output devices, interacting with the computer. Okay, so we know how data is stored, but how does it actually get into the computer in the first place? And for that matter, how do we ever see the results? Well, it's a two-way street. Input devices do exactly what the name implies. They give data or instructions directly to the computer. Output devices do the exact opposite. They take all that processed information and deliver it right back out to you, the user. Let's look at some everyday examples to make this super concrete. On the input side of things, we have the keyboard, mouse, scanner, microphone, webcam, and touchscreen. When you type your name using a keyboard, that keyboard is acting as an input device, physically feeding your instructions right into the machine. On the output side, we have things like monitors, printers, speakers, projectors, and headphones. When you open a document and read that exact name you just typed, the information displayed on the screen means your monitor is functioning as an output device. Simply put, input is giving data, output is getting the result. Section 5. Real-life data journey. The life cycle of a college project. Let's tie all of this together. Imagine you are sitting at your desk late at night, grinding away on a big college project. Step 1 is input. You start typing out your assignment using your keyboard. Step 2 is processing. The internal computer components take those keystroke instructions and rapidly handle the data. Step 3 is output. The computer utilizes your monitor to display your progress so you can actually see the essay you are writing in real time. And finally, step 4 is secondary storage. You hit save. Thank goodness. The project is safely routed to your SSD or hard disk. Because it is saved in secondary storage, you can safely power down your machine for the night. Even after the computer is entirely off, your project remains perfectly secure, and you can open it right back up the next time you turn the system on. This incredibly simple flow, input to processing to output, all permanently backed up by secondary storage, is the fundamental connection of how every single computer system operates. And finally, Section 6, Final Summary Core Concept Review. Let's lock in these absolute non-negotiables so you can ace your exams. First, RAM is your temporary, immediate working memory. Second, secondary storage is your long-term, non-volatile storage where your data absolutely survives a power loss. Third, input means data goes into the computer. And fourth, output means the processed result comes out to you, the user. Keep these simple definitions in your back pocket and you'll be golden. If you found this concept breakdown useful, be sure to hit that like button and share it with anyone else who is trying to master computer hardware. Let us know down in the comments if you want us to do a dedicated Q&A explainer to test exactly how these concepts appear in real-world exam scenarios. But before you go, I want you to think about this. As our world currently generates millions of gigabytes of data every single second of the day, how will the secondary storage devices of the future need to evolve to somehow hold it all? Think about that. Thanks so much for joining us for this explainer, and keep exploring.